Dear colleagues, good afternoon, good morning to all of you. Thank you very much for joining today's webinar. My name is Željka Knežević and I'm a Working Group 12 chair. It's my great pleasure and honor to welcome you on 10th EURODOS webinar, which is dedicated to the topic from Working Group 12. The topic will be accuracy and quality control of skin dose mapping software results from VERIDIC project. So at the beginning, just a few notes. This webinar will be recorded and it will be available on EURODOS YouTube channel a few days after the webinar. Also, you can post your questions in Q&A section, and after finishing with both lectures, we will answer to all your questions. At the beginning, I just want to say a few words as introduction about EURODOS Working Group 12. EURODOS Working Group 12 is dedicated to dosimetry in medical imaging. On our new EURODOS web page, you can find details about all working groups and also about Working Group 12. Working Group 12, the aim of the working group is assessment and improvement of patient and staff dosimetry in the medical field, but excluding radiotherapy. The topic of radiotherapy is covered by Working Group 9. Working Group 12 is focused on patient and on staff dosimetry in different fields, medical fields, in diagnostic, in interventional radiology, and in nuclear medicine. And our overall aims are focused on dosimetry issues, on harmonization, on development of the dosimetry methods, on preparation on different recommendations, organizing intercomparisons, literature reviews, different measurement campaigns, and all this in order to assess occupational and patient exposure. Working Group 12 is actively collaborating with IFOM and also with ENMA on several tasks. And our members are including experts from a medical physicist community, from research institutes, from reference laboratories, from dosimetry service, and from regulators. At the moment, we are working under two subgroups. One subgroup is staff dosimetry, led by Isabelle Clarand from RSN France. And here you can see several tasks that are currently ongoing concerning staff dosimetry. We have tasks on eye-lens dosimetry, then on doses in complex interventional procedures. Then we have tasks dedicated to nuclear medicine, to extremity doses in nuclear medicine, with focus on new radionuclides. And a task also on operational exposure during preparation and administration of new radiopharmaceuticals. The second working group is patient dosimetry. It's led by Marta San-Mercé from Switzerland, and currently we have 5 ongoing tasks. Dedicated to skin dose in interventional radiology, then task on personalized dose in radiotherapy, and this task is jointly performed with Working Group 9, one task dedicated to dosimetry in pregnancy. Here you can see task leaders, and if you are interested in joining any of these tasks, you can write an email to me or to Eleftheria, who is the secretary, or to task leaders, and we will be very happy if you can join and work together on these tasks. I will not take much time because we have very interesting lectures today. I just want to say a few words about this VERIDIC project. The title is Validation and Estimation of Radiation Risk, Radiation Skin Dose in Interventional Cardiology. And this project was initiated in working group 12 in one of the tasks in subgroup 2. It was a concert-funded project, and most of the partners were and are members of working group 12. In this project, the coordinator was Jeremy Dobbin from SEK, and we had 10 partners from different institutes and hospitals across Europe. The objectives of the project were to review existing skin dose measurement software products, to see where harmonization needs to be implemented in radiation dose structure reports from maximum skin dose calculations. Then one of the objectives was to compare different softwares, their capabilities and accuracy, and investigating skin dose determinants for dose optimization. The project was successfully finished, and today you will hear the main conclusions and the main results from this project. Now. It's my great pleasure to introduce the first lecturer, Jeremy Dobbin from Belgian Nuclear Research Center. Jeremy is a senior researcher in SEK, and he works in Working Group 12 since 2010. It's in 2010. Also, he was the coordinator of this project, and also he received Eurados Young Scientist Award in 2017. His main research interests are focuses on patient and staff dosimetry during medical imaging. He is participating and participated in several European funded projects. And as I mentioned, he successfully coordinated the VERIDIC project. So today he will present the results from the VERIDIC project. Jeremy, the floor is yours.
Thanks for the kind introduction, Jelka, and good afternoon, everyone. So I think if you are attending this meeting, you are all aware of the advantages and the advantages of interventional cardiology. Of course, fluoroscopically guided procedures are really nice, like just using X-ray guidance. You can insert a catheter into a patient and treat that patient, and advantages are really obvious. But of course, the disadvantages of using X-rays to guide a catheter is that the skin dose to the patient during the procedure might be pretty high, and if you consider that multiple procedures can be performed on the same patient on the same region, then you have risks of having radio-induced skin injury, as you can see here on this picture. I don't have a pointer, so that's why I'm drawing. It's not that I have any talent for it. And I think it might be one of the most famous picture of radio-induced skin injury, or at least you probably have seen that patient back very, very often. You can nicely see dermatitis appearing and like the radiation field on the patient back. And of course, and also nowadays we are also more interested in the possibility of radio-induced cardiovascular disease. So that's another issue. The problem with those high skin doses is that it's really difficult to predict where it will be, and then different software tools have been developed. And it's not something really new. Already 20 years ago, software appeared. You have here an example of the CareGraph system, and here you have other example of more recent software tools. You see a nice one where you even see like the X-ray beam painting the dose map on the patient back. But even more recent, better looking software tools still have some limitations. Like the capability, the accuracy of those software can vary a lot from one vendor to another, from one procedure to another. There are some data that are missing or not properly reported in the radiation dose structure report to allow the proper calculation of the skin dose. And also quite important, I think, for the people attending here is that there is no quality control that exists to test in an homogenized way all those different software tools. So that's why the VERIDIC project was initiated, and happily it was funded. I won't go again through the objective, but here I will focus mostly on the review, on the limitation of the skin dose mapping software, and how it affects the accuracy. So yeah, I will directly start with the review, then we jump to the measurement result later. So here is a non-exhaustive overview of contemporary products. It was published last year. Okay, there is a bit more than 20 products. Of course, there are many more that exist. It's possible that many software tools appear since this last review, but you can already see that they are here. You have the software name, here the company name. You can see that some software products are produced by great, big and geography unit manufacturer. Other ones are just non-commercial one. You might not have access to it. Some are open source software tools you could access. And then within the frame of the project, we performed a review based on which calculation algorithm was used, which factors were accounted for in the calculations, how was the patient represented, were there validation studies published in the literature or not, and so on. The calculation algorithm, that's actually quite simple. A few software tools use Monte Carlo simulation, but that's not very common. And really, most software tools out there, they use a simple analytical approach. So it's just this formula here that is used for every irradiation event. So each time the X-ray system produces some X-rays, this formula is used, and then at the end of the procedure or during the procedure, depending on the system, the skin dose is calculated and the sum is calculated for all the irradiation event. And the basis of that of those skin dose calculations, it's the air karma, so kind of a dose metric that you dose output from the X-ray system. And that air camera is corrected with different factors. You have the calibration factor that indicates what's the accuracy of the air camera that is displayed in the system. You have the transmission coefficient of the table and the mattress. So what is the attenuation, or how much X-ray do the table and the mattress do they transmit? You have the backscatter factor, so caused by the patient. And you have a correction factor for the actual distance between the reference point where the air camera is estimated and the actual patient entrance. And finally, you have the F-skin factor, which is just a factor that's necessary to convert air camera into skin. And that's, again, that's not something new. Already in 2011, that was published, just to cite that reference. And already from that formula, you can have an idea of what's the uncertainty in the maximum skin dose or in the skin dose calculations, because it's just a product of factors. So any error in one of those products would directly result in an error in the skin dose estimate. And you directly see the issue here. For example, if you look at the backscatter factor, you can have ratios for the energies and patient thickness considered in interventional cardiology. Those ratios, they can range from 120 to 170. So it means it's about 50% difference between the two extremes. And how are those values selected by the skin dose mapping software? It depends. Some software might just use a single value. Other software might accept the value selected by the user and or multiple values based on a data available in the RDSR, and then selected based on the KV, the filtration, the patient thickness, and so on. And you can see that the difference, the range of possible backscatter value is large. So a possible 50% error, which means possibly 50% error in the skin dose. But that's also the case for the table and mattress transmission. You can see here that it's about 60 to 90% the value of the transmission. And if you consider that lateral projection where there is no mattress or table in the beam, it's even 60 to 100%. So again, between the two extremes, it's about 50, no, even about 100% difference. And also the dose matrix, the air camera that is used as basis for the skin dose calculation, a quite large uncertainty is tolerated depending on local legislation, but it might be the value is correct within 25, 35%. So again, that can possibly cause a large error in the skin dose estimate. And finally, that's the only good news, I think, the F factor to convert the dose in air to skin. Here, the values, the range is very small, so it won't have a major impact on the skin dose calculations. And yeah, how does that? Sorry, I forget. And it's not in the formula, but it's very important. Of course, the selection of the patient model. Depending on the system, you might have very simple shape that are used, like just a kind of cylinder or some combination of elliptical shapes. You might have anthropomorphic phantoms, just one phantom, or you can select between several phantoms. So that will also have an impact on the selection of other parameters or on the final calculation of the skin dose. And the limitations, the current limitation of the skin dose mapping software product, of course, they are all linked to those parameters and the patient representation as I just presented you. And to summarize the major limitation that still needs to be addressed before having, let's say, perfect skin dose estimated, there are first the missing data fields or the missing data in the RDSR. For instance, the air camera, it can be calibrated, but only one value can be filled in the radiation dose structure report, although you would need much more to be accurate. And the table and mattress transmission, no values are in the RDSR so far, as far as I know. And so the field shape, the radiation field, it's not really well defined in the RDSR. Like with the information in the RDSR, you are not able to very accurately represent it. There's also lack of harmonization among the manufacturers. So the way the table height is defined in the RDSR is different if you are looking at Siemens and GE or if you're looking at Canon and Philips. Might seem a detail, but it can have an important effect on the skin dose. And also, maybe the most surprising of all is that there is no way for the current system to know what is the patient contour, the patient shape, and the patient position on the table. And you have here a very simplistic representation. For a skin dose mapping system, there is no information, no way to know if the patient is well centered on the table or if the patient is very close to the X-ray beam. And of course, it will have very big effect on the dose at the patient's skin. Also, there is no real way for the system to know if the patient is rather thin or if the patient is rather thick. So there is information on the height and weight, but that's not sufficient, and that have again a big effect on the calculation of the skin dose. And there are again other factors that are not accounted for, like the heel effect, backscatter from adjacent field, and so on. And just to give you an example, we collected data in RDSRs actually from 160 procedures in 3 hospitals, and we just feed them in 4 different skin dose mapping software. You have the list here. And then we plotted the average value of the skin dose calculated for one procedure for 4 different software. And for each software, we plot the difference. So you can see it varies a lot depending on the system and on the software. You can see that for the GE system, yeah, the skin dose estimate don't differ too much from the average. So okay, it's within 40%. it's not too bad. While for the Philips system, you can see in one hospital, there's a huge scatter. There's possibly 100% difference between the average skin dose estimate and skin dose estimate from one system. And you can also see that some systems are more likely, some skin dose mapping software are more likely to over or underestimate. And in another hospital, you see that same angiographic units, you can see that the results are different again. So all those parameters are really important. Of course, here we just compare a skin dose calculation, but we had no information about the true dose. And that's why I will present you now some measurements we performed within the frame of the project. So we selected angiographic units from the 4 main manufacturers, so Canon, GE, Philips, Siemens, and I tried to perform measurements and then feed the RGSRs from those measurements in as many skin dose mapping software tools as we could get our hands on. So here you have a list of 10 skin dose mapping software tools, and we just calculated those for all the angiographic units that were compatible. And what kind of measurement did we perform? We didn't do anything really particular. We just use a slab phantom and an anthropomorphic phantom. We considered simple configurations. And so combination of simple configuration like short repetition of short clinical procedures. And then we put different type of dosimeters on the table below the phantom, like Gaffchromic films, thermoluminescent dosimeter, and quality control multimeter. Of course, that's not something everyone has access to in a hospitals. And then we just compare measurements results with calculations. Yeah, just a detail you can see here quickly that yeah, we consider different phantom thickness, different angulations, and different type of phantoms. And I want to present you all results on the 4 different systems with all the different configurations and skin dose mapping software tools used. But I just as an illustration of the general results or summary of the results, I want to show you the results on a G unit. So we used here, you see different simple projections. So it might be just PA projection or a combination of PA and lateral projection or just lateral projection. And also we perform measurements for short clinical procedures, let's say, still on our anthropomorphic phantom. And here you have plotted the ratio of the calculations, so the skin dose calculations from the software tools and our measurements. So it means that if you are close to 100, there is no difference between the measurements and the simulations. And we consider a range of about 30% for the analysis. 30%, it's close to what's in the European guideline is accepted as uncertainty in the air camera estimates. And so you see here different colors are different skin dose mapping tools, and you see it's quite difficult to make some trends out of it. You can see that for about all configurations, the results are within 40%. So the difference between calculations and measurements is usually smaller than 40%. For some software tools, it's usually within 20%. And that's difficult to say much more than that. You can see, for instance, that some software tools, like here, those 2 ones are usually giving results close one to each other. And the really obvious observation here, it's like for lateral projection. So when the beam is like at 90 degrees, not under the table, but lateral to the patient, the results are really poor or can be really poor. You can see here an overestimation of more than 100%. Underestimation you don't see, but it can go down to 66%, and some software tools don't even give an estimate of the lateral of the skin dose when it's a lateral projection. And of course, that was just for the maximum skin dose. Most software tools also produced a skin dose map. And here you have the measurements with Gaffchromic films, and then other columns represent the skin dose distribution. That was for a Canon system. And you can see that, yeah, in general, it looks good. Like the shape and the position is rather well respected, although that for two first short procedure, you can see that the maximum skin dose is at the intersection of several fields, and that's not always well represented in practice. So to summarize the measurements, yeah, in general, the maximum skin dose estimates were within 40% of the measurements, but in some cases, and it's difficult to predict when, it could be severely off. And there were only 3 skin dose mapping products that were within 40% for all the irradiation of the Randalls and Phantom. And yeah, sometimes there was a skin dose mapping product that was within 20% for all the irradiation configuration on one system. So it means a pretty good result. And maybe the most striking result, and it was to be expected, is that the strictly lateral projections are really difficult. Like, yeah, it can be the worst result of whom maybe it's no estimate of the maximum skin dose when there was lateral projections, or just a very, very large underestimation or overestimation of the dose. So to conclude, it appears that skin dose mapping software are rather promising tools. The maximum skin dose from our measurements were usually within 40% of the measurements, but yeah, sometimes it was just a very poor estimate. And as I mentioned, there are still some major limitation to be addressed before having a really accurate skin dose mapping software tool. And it can be the missing data, like in the RDSRs, or just missing fields in the RDSR, so you cannot even put those data in the RDSR, and so there's no data to calculate the skin dose. The lack of harmonization of the manufacturer, and maybe one of the most challenging one, it's the difficulty to determine the patient's contour and position. Like, you need to know where the patient is on the table to be able to accurately calculate the skin dose. And so just to open a bit the discussion, you can say, yeah, it's nice to see some results on the accuracy of the skin dose mapping software tool, but what can you do with them? Well, before doing something with them, I think it's really important to perform some quality control. Like you have seen, the difference can be huge between different configuration, between different software tools, between different angio units. So you really need to know your model. And when I say know your model, it's not only your angiographic model, it's also the algorithm used to calculate the skin dose and which data are available to your algorithm. It can sound a bit stupid, but you should also know your patient. And when I mean you know your patient, I just mean you need to know how thin or thick are the patient usually going to be, because it can affect a lot the result of the skin dose mapping system. For instance, if you have really, really obese patients, it's likely that your skin dose mapping system will underestimate the skin dose, particularly in lateral irradiations. If you have only thin pediatric patients, you're likely to overestimate the skin dose. And finally, you should also know your physician, knowing which kind of practice the physician is using. Like, if you use a lot of lateral irradiation, that will be very challenging. Maybe you should change physician, actually. And then really, yeah, I think it's too early to think about replacing dosimeters for individual patient monitoring. You have seen in the result, the accuracy can be very low in some cases, and anyway, who is performing measurements with dosimeter? That's true. And you can think about also, what about replacing the air camera, those metrics with maximum skin dose, or I would think even better, how to use them together. And so you should you should consider are you able to evaluate those trends with those with the maximum skin dose? Are you able to optimize those? And I won't answer really that question, but I will. I would just want to remind you of those results. You can see that using different software tools, you can have very different results. And the purpose, it's not to select the skin dose mapping products that will give you the lowest dose or the highest. It's really to try to correct it to eventually reach a situation where all different skin dose software tool would give you the same result, like the correct result. I thank you for your attention. I also just want to thank all VERIDIC partners who helped for this project, and of course Babs, Kerting, Gertin, and Jelka, who helped setting this this webinar and pushed a bit to keep it in 2021. Thanks.
Okay, thank you, Jeremy, for a very nice overview of the results. We have some questions, but we will answer the questions at the end of the second lecture. And now it's really my great pleasure to introduce our next speaker, Andy Rogers. Andy is currently a lead interventional medical physics expert at Nottingham University Hospital. His current research interests are skin and staph dose assessment and optimization in interventional radiology and cardiology. He is currently chairing the UK working group investigating how best to set the DRLs in interventional procedures. Also, he is recently member of ICRP working group that has published a report on diagnostic reference levels. And he's co-opted on two international working groups which are looking at quality control for radiological equipment in general. One group is IEC, and the second one on angiographic imaging equipment from EFOM. So I think he's a perfect person to give us the next lecture. Please, Andy, the floor is yours.
Thank you very much, Jelka. I hope everyone can hear me okay.
Yes, perfectly.
Yeah, great. Okay, the tech is working. That's a big step forward, isn't it? And actually, the introduction's probably longer than my talk. And I was thinking, whilst Jeremy was going through those excellent results from the VERIDIC project, that what I'm going to talk to you now is a little bit more qualitative. So I'm going to talk to you about the EFOM skin dose protocol, which is part of the wider working group protocol on angiographic and fluoroscopic quality control. So that this makes up a very small part of that, but it was felt it would be useful to let you guys know what was going on in the background. So what I'm going to talk about is the background to that working group protocol. I'm going to talk to you a little bit about how we're approaching differences in testing philosophies, if you like, between acceptance and commissioning testing. I'm then going to get into some, I was going to say detail about the skin dose and the EFOM protocol, but actually there isn't a lot of prescriptive detail in there. And I think that'll become clear. I think that should become clear from what Jeremy said, and hopefully it'll become clearer when I finish my talk. And then at the end, I want to give you some clinical context for all of this and how we need to exercise judgment when we're interpreting results. But before I go on, I'd like to sort of get a feel for the audience. So I'm going to ask you to do two polls. So Babs, could you launch the first poll, please? Okay, the results are coming in. Goodness, there's a lot of people out there. I didn't know how many total delegates there were today. I've just tried maxing Babs, so it doesn't seem to be working. So I can just tell everyone what's happening. So the question was, oh, here we go. Thanks for that. So as you can see, the vast majority of us, because we're all in this together, have never tested one of these products. But there are a few out there who said yes. So I'd like to ask those who said yes. Can we go to the second poll now? Oh, this is exciting, isn't it? So if you answered yes to the last question, did you get a supplier provided test methodology? And I know 21 people said yes, so I'm expecting to see 21 answers. Come on, guys. Click those buttons. Oh, I might come back to that in the questions. So I'm not going to maximize this one, but very quickly, the vast majority, even bigger majority than before, did not get any information explicitly from the manufacturer about how to test these things. So this is the environment we're in. There's lots of these products, and we don't really know how we should test it. So how on earth is eFont Working Group going to give you guys a guide as to how to test it? And as you'll see as we go through, the answer is not very prescriptively. Anyway, so let's crack on because we want to leave plenty of time for questions at the end. So a little bit of background about the working group. It's officially called the Angiographic and Fluoroscopic Systems QC Protocol Working Group. Very grand, led by Annalisa Triani, who's recently moved within Italy from Udine up to Trento, up in the Alps. And we're hoping that a final draft for wide consultation will be available early in the new year. And by wide consultation, that's the larger group that the working group has been working with. And then I don't know what the eFont process is after that. Might be a little bit later, depends how quickly Jeremy writes his bit. Oh, sorry, mate. And what are we going to cover? We're going to cover the mechanical and geometrical aspects of testing, stuff to do with the X-ray beam generator side, so the tubes and generator aspects, something to do with detector aspects, so that's capturing the image, the bit I've just missed, which is dose indicators, and I think included in there or separately will be the discussion on skin dose. We're going to have something on technical image quality, which is this is another area where the state of the art is not well defined at the moment. And there'll be a bit about some radiation protection discussions. That's a sort of overview of the scope of the project. So it's quite wide in its application. Some sections will be prescriptive. In other words, this is what you should do, and this is how you should do it. And the reason for that is because there's a good history of testing in those aspects, and we're pretty sure that we know what we're talking about. However, where the state of the art is not well defined, I think you'll find that the protocol is a little bit more discursive. In other words, it'll give you pros and cons of different approaches. It'll give the reader a guide as to how they might choose to go about things themselves. There won't be anything in there about optimization. And the skin dose bit, which doesn't include explicitly anything about the radiation dose structured report, which I think we now should be calling the enhanced structured report or something like that, because the new version's out, isn't it? Probably haven't been implemented by many manufacturers or systems yet. This discussion, though, will include both the systems that are attached to X-ray systems and those that we use in offline patient dose management systems. And I think we need to accept there's probably a different application and context for those. And I'm going to come back to that later. So I want to just say how we in the working group are approaching the difference between acceptance testing and commissioning for general testing. And I'm going to talk specifically here about skin dose modeling. So our view is that an acceptance test is a test designed to show that the results you get are as specified by the manufacturer. So if it was a simple dose check, you'd want to know that the dose was in specification. So if you're going to do an acceptance test on a skin dose mapping or a dose mapping product, you need to know the manufacturer's model. Otherwise, you don't know if it's doing what it says it should be doing. It's not about is it right or wrong in the real world. It's does it do what it says it's going to do? So Jeremy has already shown that there are many different models. So I will reiterate this point over and over and over again. You've got to know your model. What's the algorithm behind it? What patient phantom are they modeling against? And then how you test against that? Well, it's easy. You just test against the model. I will come back to that point. I'm being slightly flippant there. Commissioning is really a test designed to show how your device is performing in a clinical environment. Now, you don't actually need to know the manufacturer's model for the skin dose. You just need to see the results and compare them to the real world experience. But I would suggest that even in commissioning, it really helps to know your model. So getting into more detail, in terms of the general stuff about what the protocol will say about skin dose assessment, it's going to have some sort of introduction because I think this is an area still in flux. We're still learning about the products are evolving. So there's some background stuff there about the technicalities, about how the products work, the definitions of absorbed dose versus cumulative air coma, which Jeremy has already alluded to. So I'm not going to go into that in any detail. If you want to ask questions at the end, feel free. It discusses the regulatory requirements, which are almost non-existent. In the UK, they are non-existent, and equipment standards. And I'm going to just say a quick bit about that in a second. And it also explains the modeling of skin dose and the relevant factors required to give the reader a more basic understanding of how these numbers are arrived at. And Jeremy went through the formula very precisely in his talk. So again, I'm not going to be repeating that. So coming on to the standards, the equipment standards that we all have to live with because they're international standards. The current version of the interventional X-ray equipment standard, which is that top one, IEC 60601-2-43, says it should have a dose map. And it says we prefer a skin dose map where possible, where skin dose is the absorbed dose to skin. So much more relevant to how a patient is going to react to that radiation. And what you're not allowed to do is to say it's a skin dose map where it isn't referring to absorbed dose to skin. Otherwise, it has to just say, I'm a dose map. It's not allowed to say, I'm a skin dose map. Now, there is another IEC standard that I'm on the working group for this, and it's quite a task actually, getting everyone to agree on how you should acceptance and constancy check test radiographic and fluoroscopic equipment. This project will not address skin dose map testing in the main text. There's no agreed consensus whether we can get something in an informative informative annex. I think that's the right terminology. I don't know yet. And we're currently out for the CD2 draft. That's being drafted at the moment. We're hoping to go out to a vote early in the new year, sometime around Easter. There is also in the general X-ray equipment standard something that says the following. Accompanying document shall, that means it has to, contain certain instructions for manufacturer recommended quality control. Now, looking at all those answers to the polls, it's absolutely clear that very few of you have been given information from the manufacturer of the X-ray equipment, how their models actually work. Some do, but even fewer of them will tell you how to test it. And I looked recently, just as an example, at a Philips Azurion instructions for use with all the accompanying documents, and I couldn't find anything in there that they were recommending me how to go away and test their in-lab skin dose map. Now, this standard applies to interventional as well. So whether this is something that we can enhance in further versions of these standards, we'll wait and see. The intention with all of these tests is that they are simple, because not everybody out in the field has access to complicated or sophisticated test equipment or expertise. So whatever we come up with as a test protocol for skin dose mapping, it's got to be able to be implemented by everybody, not just people in academic centers. Okay, running out of time, so let's crack on. What does the protocol actually say? Well, for acceptance testing, it says if there's a manufacturer protocol, then follow it. And we've already seen that's a bit of a dream at the moment. So how are you going to do it otherwise? Well, there are various ways you can do it, but essentially you're going to have to put something on the table, irradiate it, make measurements, and then see how well they compare to the model, not real world, but the model that displayed. So for a PA projection, you just put a block of something on the table. If you want to know how well it deals with overlap and oblique projections, then you could use a phantom that mimics their model. If you have one, you might not have one. You could use your same phantom, but it would be harder to predict exactly what the overlaps would be on a different phantom. You're going to have to get into some trigonometry and some algebra for that, which takes us back to our school days. And if the model employs varying phantoms, do you want to change the phantom to mimic varying patient size? So there's lots of things you could do and many ways you could do it. So you can start to see how difficult it is actually to write a protocol in this area at the moment. In terms of commissioning, this is all about what does our system do on real patients? And this is the most difficult question, I feel. And it's very hard to do without serious resources. Gaffchromic film you could use. There's calibration issues with that. And where do you put it? Do you put it on the table or do you wrap it around the patient? If it's a neuro case, not many patients are going to like Gaffchromic film wrapped around their head. It depends what it is and what the model was. And I'm not sure many people are going to commission using Gaffchromic film. Then we get on to, okay, so we do something like acceptance testing. So we put something in the beam and we test it for the real world. So we see what the numbers the model gives us, what our machines say or our software says, and then note the differences from what we might predict are real patients. And this is going to require a lot of judgment. And there's no rehearsed way for doing this. I think there'll be lots of different ways of doing this coming into the literature over the next few years. One of the things I would like to say, though, because I come from a clinical background, so I'm interested in what's happening in real patients, I would just beware most models are likely to underestimate for large patients, especially in lateral projections. And these are the patients we want to be especially careful about. Quickly about clinical context, what's it all for? So for the equipment, the imaging equipment-based system, this is really the intent of it is for mitigating skin dose effects during a case. So it's to give the clinician information in real time about how can they slightly angulate in a different direction just to stop a bit of overlap if the dose is getting too high in that position. So that's the point of the imaging equipment-based systems. My honest opinion is that the patient dose management systems are normally used after a case because they take the radiation dose structured report at the end of the case and then they create a skin dose map. So normally, in my view, these would be used in follow-up. If you triggered in lab, if you thought this was a high skin dose, you could look at your software-based system, have a look at what it was predicting for the peak skin dose, and then maybe do something about it. So you could actually validate those results with an in-lab system if you have it and see how the two compare, so that there might be other information for you to use. And this trigger would usually lead to a patient some form of communication with the patient. And in a lot of countries around the world, this will be giving them a leaflet and saying, if you get a reddening in this area, give us a ring. And if you're worried, we'll have a proper chat to you or call you back in. And I don't think for this, the absolute accuracy is a big deal. We want to know, was it trivial or was it serious? And people will have their own views about clinical risk and where you fall in that band from trivial to serious. Certainly, I think the serious side should have a positive follow-up from the clinic, from the interventional clinic. And I think in our environment, we'd probably want to follow up, given the inaccuracies in these systems, somewhere between 5 and 7 gray peak skin dose. I'm not too worried about the 1 to 3 gray level, quite frankly. Right, finishing off now, I think there's a responsibility on us all to exercise some judgment in how we're using these tools at the moment, because there is not a good history about testing them. There is not a good history about the right and the wrong way to use them. So I think you need to take a lot of things into account as a medical physics expert in the field when you are working out how you're going to use these products. What resources do you have? What's the X-ray unit used for? Is it high dose or low dose? What are the risks? What are your current doses and the protocol angulations that you use? Have you got cases like prostate arterial embolizations, for instance, where they're going through a thick part of the body, the pelvis, and they use a lot of oblique angulation. So you're already in a very high dose situation. And if you've got large patients, that's going to exacerbate it. How do the clinicians interact with the in-lab systems? Some are more user-friendly than others. So how are they actually using them? What are you going to advise them? And maybe these clinicians require some directed or dedicated training in these products, either by the supplier, either us by the supplier, sorry, we need training. We need the suppliers to tell us how they work, how we could be testing them on their equipment or with their software. And I think we should be educating the clinicians about the uncertainties and how they use them in the real world clinic. So that was a very quick romp through, if you like, the clinical context. And I'll hand back to our facilitator and chair for the day, Shelke. Thank you very much. And I hope that was okay.
Thank you, Andy. Thank you very much. And I also want to mention that I'm very happy that this working group recognized the work which has been done within Eurados and VERIDIC project, and that Jeremy and Francoise joined this group as Eurados Working Group 12 representatives.
Yeah, they're very welcome.
We have some questions in the chat area, so I can read and you can decide who will answer. So Massimiliano Porzio asked, what about pairing the X-ray unit with stereoscopic cameras like the ones used for patient positioning monitoring in radiotherapy? Maybe it will be possible to estimate skin surface.
Yeah, I think I can answer to that. It's a really nice idea, and we have at the CKCN we have worked on that topic, and I must admit in other centers also. And yeah, I think that's the solution to it, to that problem. But of course, it's better if the intergraphic unit manufacturers are also involved, and if they can provide data during the procedure, if you can couple the camera with the modality. But that's a really difficult part. They don't seem that much interested, actually.
And I think maybe one reason for that, Jeremy, is that what's the benefit? So if we properly get to understand the differences between, as the in-lab and the patient dose management software products improve and their ability to use more realistic patient models comes into play, what is the difference between that modeling and real life? And as that difference becomes less, what is the value in going to a whole new level of complexity to predict these things? So I think there's a lot of unanswered questions, but I do agree if it's going to happen in the real world, it's got to come from the equipment, the imaging equipment manufacturers, because most places in the world aren't going to have the resources to design almost like research systems as an add-on to their interventional laboratories. I just don't think that will happen. So I think it's a really good idea. It would increase precision. Whether the value is worth the expense, I don't know.
Just to add, yeah, I think that's also a bit the attitude of the manufacturer, but also I would expect that cameras would appear more and more, like they might appear on CT systems. I wouldn't be surprised if they would start appearing, but indeed it's definitely something that would need to come from the manufacturer. I don't see many hospitals where they would install a camera and develop a system to calculate the patient's skin dose, not in radiotherapy, but in interventional cardiology, for instance.
Okay, thank you. And another questions from Augustine Ruiz Martinez. What kind of, I think you can both address this question. What kind of quality control do you consider would be adequate?
Okay, well, I don't think, unless you have a software upgrade or a new unit, that you need to do regular tests, because these are software driven. Unless the software changes, the answers it's given should not change. So we regularly test, don't we, in interventional equipment, the input parameters to these models. I think where quality assurance comes in is, are we going to be doing acceptance tests or commissioning? I think the most useful for a clinical context is commissioning. And then we have the problem, how are we actually going to do this? And I have to confess, I've only played with this once, and I got some Perspex blocks that are reasonably ubiquitous around the world, 30 centimeters by 30 centimeters field of, size, of various thicknesses, and did various angulations where I knew there'd be overlap. And I basically looked to see whether the numbers I got were roughly right. I didn't have a specification to work to. I wanted to see if I irradiated the overlapped bit to, say, 3 gray, which I can say takes a little while when you're testing a lab. You've got to keep going for quite a long time. Do I get roughly 3 gray? Do I get 2 or 4, or do I get 10 times less or 10 times more? And I think that's almost the level in the field we're at the moment. It might sound very crude and a bit silly, me having to say this, but I genuinely don't think I can do much better than that at the moment. Jeremy?
No, I agree. It takes a lot of time and a lot of means if you want to do something really accurate. And I don't work in a hospital, but I wonder, and I think we don't need a poll for that. Who has time in hospital, like manpower and time on the machine to to do that, and the material also. Yeah.
Thank you. I don't see any more questions in chat area, but
Can I ask a question? I'd like to ask Jeremy a question, if that's okay.
yes.
No, genuinely, because when you showed your results and the differences between measured and calculated, one of the things I think is very important to us in the field is that difference between the two. Is there an element of it that's an offset and an element of it that is linear with dose? Or is it 40% wrong at every dose? Because if it's, say, half a gray out, but it's half a gray out at all doses, I don't care. If it's 50% out and I measure 10 gray, but it could have been 5 or 15, that's a big difference. So what's your feeling about that from your VERIDIC project results?
Yeah, and actually it's a very, very important question because that's actually what you are interested in eventually. I mean, in clinics. For the measurements, we don't have the data really to answer that question. I mean, we didn't repeat the measurements with different doses, and as you said, it takes so much time to have the enough dose surely when you use Gaffchromic films. From when we compare the RDSR, so when we had no measured dose value, when we just compared RDSRs with different systems, it looks like sometimes there is clearly an offset for a specific skin dose mapping system on some angiographic units, because you could see that it was always way above the mean or way below. But I didn't see a correlation with the dose. So I cannot say that there is a skin dose mapping system on a specific angiographic unit that overestimates more the dose when the dose is high or underestimate it more. I couldn't see a relationship. And actually, yeah, if you would have a lot of RDSRs, you could already have a look at it. You might not be able to say if there's a correlation, but you might be, yeah.
So maybe now, to give another quick response to that last question about quality assurance, maybe if we're testing our systems, however crudely, in our own laboratories when we're accepting and commissioning new facilities, we should test at maybe 2 or 3 different dose levels with the same geometry, just to see how we think those differences are changing with dose level. Because I want to know, I don't care what the precision is at 2 gray, I want to know what the precision is above 5 gray.
Your discussion initiate another question, so I think I asked to Babs if we finish 2 or 3 minutes later, but it's okay. So maybe the last question. In my experience, the big difference are due to geometric inaccuracy in algorithm because of the RDSR interpretation.
Yeah, so based on that comment, it would be then that if I'm correct, that the inaccuracy, it's not related to the dose, but just to the geometry, and I would think that's reasonable, but of course I cannot confirm it with measurements, but that sounds reasonable.
I would guess also that that's the biggest error in real world life to the model, is the difference between where the model is saying it's trying to measure. Is it a plane on the table, or is it a patient contour? Most these days are patient contours, and that patient contour is normally a phantom, and how realistic is that phantom to real world patients? And that's where the errors are coming in.
And just to add something, you have some skin dose mapping software tool that have really nice phantom library, so you might think you are able to represent any patient, but the really difficult part there is to select the proper patient. And, yeah, and just the height and weight might not be enough for that, unless you're lucky.
Thank you, Andy. Thank you, Jeremy. We are just at the end. Thank you so much to presenters, to Andy and to Jeremy. It was very interesting, and I'm sure when EFOM protocol will be finished, we can again organize some webinar or some lecture, because there will be interesting things to show. So thanks to presenters. Also, thank you for the questions. If you have any other questions or comments, you can address directly to Andy or to Jeremy. And I just want to give one announcement at the end. Probably most of you heard, but just to keep in mind that due to this COVID situation in Europe, the Eurados Council decided to postpone the Eurados annual meeting, which was planned for the end of January. But Eurados Council and we are all against to shift it completely to online. So the annual meeting is postponed to June 2022. Still, it's planned a physical meeting in Belgrade. So take a look on Eurados webpage and follow the Twitter, Facebook, and all other channels, LinkedIn, and you will get the information about the status of the annual meeting. So thank you very much. Thank audience for joining today's webinar. This is the last webinar, Eurodose webinar for this year. The next webinar is planned for January. The announcement will soon be launched. I wish you all happy holidays and hope to meet you soon in person. Thank you very much. And thanks to Babs for guiding us through the webinar. See you. Bye-bye.